All right, let's begin. Questions on the homework? All right, settle down, because I can't hear. Integral from -1 to 1.
With e dx over x squared minus 1.
Over x squared minus 1 dx. What did it say?
Trying to determine whether it's convergent or divergent. And if it's convergent like this.
Okay, so how would you figure out if it's convergent or divergent?
Oh, wait. It's e to the x. E to the x squared on the bottom.
E to the x squared on the bottom?
I mean, e to the x minus 1. At the bottom, yeah.
Oh, that's
denominator.
Well, that's why I couldn't do it.
Oh, yeah. Before you couldn't integrate that, you'd probably try to use some sort of comparison theorem.
Yep.
Yeah, that's it. So, what's the problem here? What was the bad point? 0 was the bad point, because by plugging x equals 0, e to the 0 is 1, 1 minus 1 is 0, that was the bad guy. You just split it up, -1 to 0, e to the x over e to the x minus 1 dx plus 0 to 1, e to the x over e to the x minus 1 x. So here you have the limit as, say, n approaches 0, -1 to n. And of course here we're approaching 0 from the left side. Plus the limit as m approaches 0 from the right side of m to 1, e to the x over e to the x minus 1 dx. So this is the limit as n approaches 0 from the left. What's the integral of e to the x over blah? ln e to the x minus 1 between -1 and n plus the limit as m approaches 0 from the right of ln e to the x minus 1 m up to 1. So what happens when I start to, well, I have to plug this in first. Plug in n, so this is ln of e to the n minus 1 minus, if I plug in -1, I get ln of e to the -1 minus 1. Ln of e to the 1 minus 1 minus ln of e to the n minus 1. Okay, as I let n approach 0, what's going to happen? Right, this guy's going to diverge, negative infinity, diverges. Because I end up with ln of 0, that's going to be,
You could just stop right there, right?
yeah, like I don't care about anything else.
I was asking when you partition it to expressions, if one of them diverges from.
Yeah, no, once one guy goes bad, everyone's bad. I stop here because this guy messed up. Other questions? $13. XE.
Minus x.
Yes.
Negative and infinity.
Okay, I think there was a problem similar to this on the quiz. So what are the bad points? Just the infinities, right? So I can say something like
0.
Limit as m approaches n approaches negative infinity of n up to say 0, x e to the minus x squared dx plus limit as n approaches infinity of 0 to n.
You don't necessarily have to use 0, right? You could use any point between.
Yeah, any point would work. 0 is arbitrary. I define anywhere, so I can just use that. So this is limit as n approaches minus infinity of, what's the integral of this? It's not by parts. Substitution, u equals this, du be blah blah blah, you get 1/2 e to the minus x squared. Negative, because of the negative sign. This would be n to 0 plus limit n goes to infinity of the same thing. Minus 1/2 e to the minus x squared. This became 0 and m. N goes to minus infinity. Here, if I plug in 0, I just get minus 1/2. Plus, if I plug in n, I get 1/2 e to the minus n squared. Plus limit as m goes to infinity. If I plug in an m, I get minus 1/2 e to the minus m squared. Plus, plug in 0, I get 1/2. Okay, so as n approaches negative infinity, what happens to this term?
0.
This is going to go to 0. So I'm just going to get minus 1/2 here. And here, as m approaches positive infinity, 0. Because I'm just squaring the term and then taking its negative. It's always going to be a negative number. That's going to be 0. It's negative infinity. And so I would end up with what?
Negative 1/2 plus what?
Plus 1/2. Here. So it actually converges to 0. Because this guy, the e to the minus x squared is actually symmetric about the y-axis, and then the x is positive on one side and negative on the other side. It's actually an odd function, so you get 0. Couple more questions. One more question, and then I have to add some.
A quick question. Let's say we have one of these questions and there's an ln involved, ln of x involved. Does that always give you infinity? Like, no?
No?
Well, if it goes to 0.
It depends. It could be whatever.
No, it's still comes.
ln doesn't guarantee it diverges. No, not necessarily.
If you use the u substitution, can you use the limit and change the limit?
If you use a u substitution, what happened?
Yeah. Like 1/2 e to the u and change the limit.
You could do that. Yeah, you would have to change the limits though.
Yes.
So you would have u equals minus x squared. Your du would be minus 2x dx. So you'd have minus 1/2 du equals x dx. So you would have minus 1/2 over here. You'd have e to the u over here, du. And then what you do is you change the limits. So then you'd be like, when x equals to infinity, this means that your u would be what? Minus infinity. And when x equals minus infinity, your u would be what? Again, negative infinity. And so this would go from negative infinity down to negative infinity, which, so technically you'd still break it up. I know technically you can't just say it's 0, even though it's the same number to the same number, because it's like infinities. You'd still break it up and you'd plug in the limits and you'll end up with that. it's still improper. Because infinity is weird. One thing though I realized I made a mistake. I didn't give you guys as much homework as I should have.
Yeah, there wasn't any question.
There was no
Comparison.
comparison theorem
Yeah.
questions, which I think, so in your own time, in addition, do, I think problems 41 to 46, those are the comparison theorem problems. I meant to give you those, I don't know why I didn't type it. Maybe we can actually do a couple. I think I took a picture of it. So basically, the question said use the comparison theorem to determine convergence or divergence. Right? There are problems like that in the review for the test, but it'll be nice if you actually practice some homework problems. What about something like this, 41? It was actually the integral from 0 to infinity of x over x cubed plus 1 dx. Converges or diverges? Why would you say converges? If you ignore the 1, you get 1 over x squared, and you know that that guy sort of behaves nicely. He doesn't behave nicely when your limit is 0, but in actuality you have a plus 1. The denominator is never 0. So I would guess he would converge, but how would I actually show it converges by a comparison?
Comparison 1 over x squared.
There's a slight problem with that. Sure, I can compare this to 1 over x squared. This is definitely less than or equal to 0 to infinity of 1 over x squared, right? By just getting rid of the 1. Well, what's the problem here?
0.
The 0 is the problem. It actually diverges if 0 is the lower limit. Where do we know that it converges? We had a theorem for this. The theorem says, when does it converge? If this were a 1, yeah, we'd be nice. So how would I actually use that to our advantage?
0 to 1.
Yeah, split it up. Do 0 to 1 of this guy. Plus 1 to infinity of that guy. Right? Now clearly that's less than or equal to, I can put this guy back, x cubed plus 1 dx plus, and now I make this denominator smaller so I get something bigger. This guy we know converges. What about this guy?
T converges, so does
How do you know that converges?
because you have two functions and you split them up, and if you do FNG, then T converges them.
Right, it's not improper on this interval, right? Everything is fine, and I have a definite integral, which means this guy is going to be some constant, right? So this guy is just a number plus something else that I know converges. So I'm just adding two numbers. So by comparison, this means, if I call this I converges by comparison. That was a slightly tricky one because you sort of have to split it in two, but it's not super maybe. How about the next one? 43. One to infinity of x plus 1 over the radical of x to the fourth minus x. Again, that was similar to the quiz problem. In fact, that was an exact quiz problem. And for the other version, I put 2 here and a 2 here, but one of them was that guy. Converges or diverges? What do you think? How would you show that?
That's greater than x over x. Square root of x to the fourth minus x.
This is greater than what?
X over the square root of x to the fourth minus 4.
You're just subtracting a 1? Then this is bigger. Yeah, but how does that help you? To write this? I mean, that's true, but how does that help?
X4 is always bigger than just X.
Yeah, but do I know about this guy? Remember, in comparison theorem, I want to get an integral that I can actually answer the question about.
How do you know if it's greater or not? Or you just, oh, never mind.
Well, here there was a plus
Yeah,
1
yeah.
in the numerator. That's definitely bigger. But looking at this function, does it... I'd have no more luck dealing with this guy than the previous guy, I think. What's another way we can change it? What's the problem?
Multiplying conjugate? No. No.
There's no conjugate for that. What makes this integral difficult to deal with? The radical, but what's under the radical, right? What if I got rid of an x? How would that affect things?
X squared.
Right. Which one is bigger? Which side?
The right.
The right side. The left side. We're removing that, so the bottom is bigger now. Also, longer to left.
Here I was subtracting, right? To get to here, I had to add x, right? And my x values are between 1 and infinity, right? So by adding x, I made the denominator bigger. This denominator is actually larger, which means this fraction is smaller. So that's the right direction. Now let's look at this guy. That would just be x plus 1 over x squared. Don't need a u substitution here.
Split it.
This is just 1 over x plus 1 over x squared. Now what can you say?
Yeah. Converges both sides. I mean,
Diverges. This guy diverges. Right? 1 over x diverges from 1 to infinity. Right? Integral of that is ln. ln of infinity is infinity. It's going to blow up. Right? Remember, we know that 1 over x to the p converges. P has to be greater than 1 strictly to converge. Right? Here my p is equal to 1. This guy's going to diverge. This guy will converge, but that guy diverges. So the sum will diverge. So it means that this guy diverges. Right? Because I have the smaller guy diverging, it's going to push this guy to diverge. So. So those are just some problems you can practice. Let's sort of get back down to earth and do something more concrete. So chapter 7.
wait, am I going to the test question?
What?
Can I go to the test questions?
No, why?
I don't know. What was the answer for the last one?
What last one?
The bonus one?
The bonus? Well, that's what this is about. That's what I'm going to tell you now.
Okay.
7.1, we're going to look at areas between curves. Let's see. I gave you the formulas here. Well, let's actually look at how this sort of works. Just don't want to spend forever on this, just to get some intuition. So here's the problem. Here I have a function f. Here I have a function g. Oh yeah, pass up the homework. Let's say I want to find A, which is the area between f and g, area between f and g on the interval AB. How do you think I would do that?
Integral A to B f of x minus
Yeah.
g.
Just subtract the integrals.
Right, you'd subtract these guys, right? Why would you subtract them?
The integral gives the area.
For fun? Just because?
Because the integral gives
Right,
the
well if
area.
I integrate a to b of f, what do I get?
The area. Underneath
The
it.
area, everything below f, right? And if I integrate the integral of g would give me what? Everything below g. Right? So if I want to find the area in between them, if I take everything and then subtract this guy, I'm left over with the area that I want. Right? So that's sort of the idea. So you sort of take f minus g, or you can even put this into one integral. F of g minus f of x minus g of x dx. Right? The idea I want you to take from this is that f was my top curve, g was my bottom curve. That's a super important concept to wrap your head around. Make sure you get that. Top minus bottom. Okay, so similar. Let's look at another situation. Let's say here I have some function doing something like this. Call that h of x. I have another function doing something like that. Call that L of x. And now I'm on my y axis. Let's go from C to D. And I want to figure out this area here. What do you think that area is going to be equal to? Oh, this can't be x. This would have to be a y.
Thank you.
Right, so this has to be x equals some function of y, x equals some function of y.
Integral of the function.
Integral from C to D of? It has to be L minus h, right? And what's my variable at the end? dy. Now, I know, it's been forever since I did calculus. Did you ever see anything like this in Calc 1?
Yeah.
The idea of a dy integral versus a dx integral? It's just like a dx integral except you turn your head this way. It's basically a change of perspective, right?
But
You imagine that the x-axis is pointing up and the y-axis is horizontal, and then top minus bottom, this would be the top, that's the bottom, so it's like right and left, right? So top and bottom becomes right and left. Basically is what happens, right? So that's what I want you to get here, right? You subtract the left. right? Because the larger x values are to the right, right? Smaller x values are to the left. So in terms of x, the bigger guy is over here, the smaller guy is over here. Okay. So here's the main takeaway I want you to get from those illustrations. So here's the main idea. There are two ways to find the error between curves. It will either be a to b of the top function minus the bottom function dx, right? That's if you're looking at things with respect to x the normal way, or we can actually turn our heads to the side depending on the function, and we're going to do examples of each. Or it's going to be right function minus left function dy. These ideas you have to know. Now there are much more technical ways I could say this, but I don't think it's necessary. I think if you get this idea, really get this idea, then this whole chapter is easy. You're going to be seeing this, it's going to be a recurring theme throughout this chapter about positions in relation to each other, top and bottom, right and left. Like a lot of things are just going to depend on that, top, bottom, right, left. The first one is area, right? So if I need the area between two curves, if they're horizontal and I can write them as functions of x, I take the top minus the bottom. If they're vertical and I can look at it as functions of y, I take the right function minus the left function. Right? That's always going to be the case, right? So here, limits are given, or you may have to solve for them. By finding intersection points. So let me draw a few more illustrations so you get the idea, and then we'll jump into some examples. Illustrations. Okay, so here, there's the F, there's the G, AB. I want to find the area here. In this case, A, B are given, right? So I'll tell you, find the area between F and G between these two x values, right? I'll tell you, between x equals 1 and x equals 7, right? I'll just tell you those values. And if you know F is on top, G is on the bottom, well, the A is just A up to B of F minus G, right? And this would be dx, right? Because these guys would look like functions of x, right? Because they would each pass the horizontal line test and vertical line test. Okay, so that will be that. Now, there are cases where I might not tell you the limits. What would that look like? So I might say something like find the area bounded by f and g, right? So these are two functions. Now, I never mention any limits here, but let's say I know that f looks like this. That's my f, and my g looks like that. Right? Which means the area I'm looking for is going to be this area. Right? That's the area that's bounded between these two functions. So what's going to happen is, I can locate these points, right? I can actually solve for those points myself and take that to be the A and this to be the B, right? So here, A, B are the intersection points. You solve for it, right? Anytime I give you a question like this, I'm not going to tell you what they are. You're going to have to solve for them. And again, the area is just A to B of top minus bottom. Right? We're going to look at how to find intersection points. But basically, you plug one function into the other. It's like a substitution thing. Okay. Okay. Here's another illustration. Tell me how you would find the area between these two functions. This is my f of x. This is my g of x. Let's assume we could find the intersection points, right? So the intersection here is A. The intersection here is B. The intersection here is C. I want the area between the curves. What area is that going to be?
Integral from A to B, B to C.
So there's an area here bounded between the curves, so that's that guy. There's another area over here bounded between these curves, that's that guy. Right? And then they never meet again. They go on and do their own thing. Right? So I have to worry about these two areas. So when you say integral from A to B of what? Top minus bottom. So in this region, what's the top? Right, see F. So in this region, F is the top, G is the bottom. So this is F minus G dx. Plus, I'm going to add this area. So I go from B to C of what? In this case, it switches. My G becomes the top function. My F is the bottom function. So you get the idea? It's always top minus bottom. Yeah.
I just do F integrals A to C.
And integrate what? No.
I just want.
Right, because your top and bottom changes. You're always integrating top minus bottom. So at any given time, if that guy switches, you'll need to break the integral up, right? So let's look at that. And again, this can happen in the reversed order, right? So we can have things like G and F is here, and I have to find that area. But this is G of Y and F of Y. Or I can tell you about functions that intersect like that, where this is F of Y and this is G of Y. Or we can have functions that intersect several times. Where this is F of Y, this is G of Y. So let's say this here is C, D, this here is D, this here is C, C, D, E. So my area for this one would be what?
F minus G.
Right minus left. So it's F minus G dy, right? This one.
G.
And this is, of course, from C up to D. This would also be from C up to D. What is it? G is the function on the right, right? G minus f dy. A little illustration that might help you. You can also imagine that there's a little man trapped in here. If he looks to his left side, what does he see? He's seeing the f function. If he looks to his right side, what does he see? The g function, right? Sometimes you might lose your orientation. You just have to pretend someone's trapped in there, and you look to your left or your right, or you look up or you look down, and you'll see the reasons for that soon. So let's do this one.
Two integrals, e to d and then d to c are
Okay, so if I'm doing c to d, what would that be?
g minus f.
Right, so g is on the right side here, right? So that's your g. This is f. Here's g, that's f. So in c to d, g is on the right, f is on the left. So that's g minus f dy plus, it can go from d up to e. In this region, f is on the right, g is on the left. So I go f minus g dy. Yeah.
Question. So what if it gives you the functions in terms of x, but they you have to change it?
There are times when you have to change it. So let's look at something like that, right? So
You have to take the inverse of it?
So not all the time are we just going to give you the functions like that. That'll be too easy. Definitely not worthy of a final exam problem, that's for sure. But what, let's say I did something like x equals y squared and something like y equals x minus 2 or something simple, right? What would that look like? This guy looks like what?
This.
Sideways parabola, right? So it looks like this. What does that guy look like?
X linear. So
Straight line, y-intercept is going to be what? Like minus 2. And what's it going to look like? Goes up like that. So now I can ask you, what is the area between these two curves?
x minus 2 minus square root of x.
And so now if I ask you, how would you set that integral up?
This function minus that function. Your top function would be x minus 2.
Would you do a dx integral or dy integral?
dy.
Why would you choose dy over dx?
It's not it passed.
So remember our idea that I wrote before. The area, you can think of it in two ways. You can think of it as top minus bottom dx, or you can think of it as right minus left dy. Okay, so now let's imagine we're looking at it as a top minus bottom. What's the issue here?
At the bottom. And then
They switch, right? See at this intersection here, right? I have a little man stuck in here. He looks up, what is he seeing? He sees the parabola. If he looks down, what does he see? He sees the line. Pretend he's stuck over here. If he looks up, what does he see? Parabola. Looks down, what does he see? Parabola. Notice that the bottom function changed. So your top and bottom on this side is different from your top and bottom on that side. So if I'm doing top and bottom, I'd literally have to break it into two parts, right? Over here, I have a different top and bottom. Over there, I have a different top and bottom, right? So doing top to bottom, I need two integrals, okay?
useful little guy.
Now, the little guy's trapped in here. Looks to his right, what does he see? The line. No matter where in here he's trapped, if he looks to the right, he will see the line. If he looks to the left, what does he see? The parabola. It will always be the parabola on his left, right? So in terms of top and bottom, there are two scenarios. The top can be the parabola and the bottom the parabola. Or the top can be the parabola, the bottom the line. Each scenario requires a different integral because it's top and bottom, right? However, there's only one function on the right and one function on the left. So if I had a choice, I would set it up this way. Right? There are times when you have to choose. I'm not going to tell you. I'm just going to, here are the functions, find the error between them. You have to figure out, okay, I need to find the intersection here, and I'd rather think of it as a dy instead of a dx. Like, you're going to have to make all these choices. Right? And at the end of the day, it's all about top and bottom, right and left. It's all it's about. Right? Do whichever one is easier. Right? Every time your top and bottom changes, you need a whole new integral. And it could go vice versa, right? So I could say something like, I could have something that looks like this, like the parabola is this way. And then this goes that way, right? So in this case, I would definitely think of this as a dx integral, right? I'd put, let's say this is f and that's g. I'd do f minus g dx. Because if I did dy, right? My little man is stuck down here. To his left is the parabola, to his right is the parabola. As opposed to if he's up here, to his left is the line, to his right is the parabola. Right and left switches on, right? However, top and bottom never switches. There's only one top function, one bottom function. Throughout the whole shaded region.
You could still do it, right? I mean,
You could do it,
you would have to
but
find the
it's
key.
more work.
2 integrals, then you're done.
Yeah. So you need 2 integrals instead of 1 integral.
Enough progress.
So those are some considerations you might have to make. Sometimes the functions themselves might be nasty in one variable as opposed to the other, so that's another consideration. But usually these are your main considerations. Top, bottom, right, left. How can I minimize the amount of tops and bottoms and rights and lefts? Okay. Is there anything else I didn't say?
So what would be the answer for this one? Like,
Now when there's
integration
set
of 1
I-
minus 2 minus square root x, or
Okay, let's actually do that one then. Fine. So this is x equals y squared.
x minus 2?
So let's actually do that one. Add more examples later, but we're not going to get to much more anyway. So let's actually do something so we can feel accomplished when we go home. So I was gonna, okay, let's get through this quickly. So let's say that's the question. Find the area between these two. So as we've already discussed, I have a choice. I can look at this as top and bottom or right and left. Top and bottom is problematic, right? It's because it changes on this side as opposed to that side. So I'm going to do right and left. Okay. So remember when right and left, what do we have to do?
Right minus left.
It's right minus left dy, which means all my functions should be in terms of y's, right? So this function here, I'm going to rewrite it as what? X equals y plus 2, right? That's how I'm going to think of this function in terms of y. This function here would be what? X equals y squared. He's already in terms of y. So as far as I'm concerned, this guy is now right. That guy is wrong. I'm kidding. That guy's left. Right? So when I see right, I'm going to think y plus 2. If I see left, I'm going to think y squared. Okay. That's the first section. Now, that's the first consideration. What's the second consideration? My limits. I need my bounds. So how am I going to find the bounds?
The x, y is, yes.
For the limits, I need the intersection points.
Both are the same y value.
How would I do that? Right, so here I know x is equal to y squared, and I also know that x is equal to y plus 2. To intersect, they have to be equal, right? So I just set them equal. Y squared must be equal to y plus 2, which means y squared minus y minus 2 must be equal to 0. How do I solve that?
Square this.
Factor y, 2, 1, minus plus, right? So this is y equals 2, y equals minus 1. So I know the limit here is minus 1, the limit up here is 2 on the y-axis. So this means my area between the curves is going to be the integral from -1 up to 2 of right minus left. Right? So I double check, go back here, what's on my right? Y plus 2, what's on my left? Y squared. So this is going to be y plus 2 minus y squared dy. How do I do that into it?
Split,
Alright.
yeah.
Easy. Y squared over 2 plus 2y minus y cubed over 3 between -1 and 2. If I plug in a 2, I get 2 plus 4 minus 8 over 3 minus, if I plug in -1, I get 1/2 minus 2 plus 1/3. So that's what? That's 6 minus 8 over 3 minus a half plus 2 minus a third. So that would give me what? 6 plus 2 is 8. It's that. Minus 8 over 3 minus 1 over 3 is minus 9 over 3.
So which is -3.
That's minus 3.
And then half.
So that's that. And then I minus a half. Right, so this is 5 minus a half, which is what?
4.5.
That's weird. Yes, technically it is 4.5.
Technically.
I write 9 over 2, but okay.
Oh.
See the idea? Like that's a bona fide problem. I could literally just ask you this, right? It's not too shabby for a final problem. Probably part B. Part A, just write out the partial fractions, don't tell me what the constants are, and then part B, find the area between these curves.
See if we can
Right? They're both sort of, they're not that bad. We have more examples, but we'll do those next time. But I guess what I wanted to do in the short time was sort of give you the intuition of how you want to set these up. It's all about top, bottom, right, and left. Right? Once you sort of get that down, you can practice some problems if you want, and then we'll do that. Thursday we have our test. Make sure you do the review problems.
How